Alright guys, welcome to 6.2, where we're talking still about systems of equations. And systems, as you recall, are more than one function, more than one lines on a same graph. We want to know where they intersect. That can help us solve some world problems. So for example, this crisis at Jefferson High School. So you want to read about this. Two high schools in Jefferson High School District are named Jefferson Hills East and West. Okay, so East and West. Both schools are taking field trips to the state capitol. Okay, they're both going somewhere. A total of 408 students from East will be going in 3 vans and 6 buses. Okay, and a total of 516 from West will be going in 6 vans and 7 buses. Notice how I'm trying to filter out some of the information here. Each van has the same number of passengers and each bus has the same number of passengers. So which means each van is the same size and each bus is the same size, kind of constraint are. Okay. So I'm going to use red for East. Okay. And then I'm going to highlight the information for East. I'm going to use blue for West. There's the key data right there. A says, write an equation in standard form. Okay, so standard form has to be in this way, sort of like 2x plus 3y equals 6, something like that. So it's got to be in the form of, can I erase that? Jeez Louise. Oh boy. Okay, so a standard form has to be in this form, ax plus by equals c, and a, b, and c are integers, which means whole numbers, excuse me. Number A says, let x represent the number of students in each van and y represent the number of students in each bus. So x is students in bus, okay, and y would be students, oops, I made a mistake, students in van, and then y is students in buses. Okay. So write an equation in standard form that represents East. So East is my red one, so I'm going to use red. So think about how many students can fit in each bus and how many students can fit in each van. Alright, so we're thinking, okay, so how many students? So we're saying, so if we added up all of the students that fit in each van, but there are 3 vans, okay, so it'd be 3 times however many can fit in a van, because there's 3 vans. And we add up all the students that can fit in a bus, and there are 6 buses. Well, you add them all up, then you're multiplying how many buses, how many people can fit in each bus times 6, and add them all up, and there are a total of 408 students. Okay, so that's the idea here. See if you can figure out how to do B. Okay, a little bit by yourself. Write an equation in standard form, again, standard form, so circle that, it's important, that represents the students from Hills West. Use the same variables as on there. So go ahead and do the same idea for your West. Go ahead and do that. I'll do it in a second, but I want you to try it out first, so you can follow the same idea here. Okay, should be done by now. So this one, there's actually 6 vans and 7 buses. They have a total of 516. So they got more buses and vans and more people. Okay. So hopefully you're able to do that one. You can compare how are they the same and how are they different. Make sure to answer that, okay? I'm not going to help you with that. You can do that. Study them, see how are they different, how are they the same, how are they almost the same. Letter D. Go ahead and finish your C. Letter D says, describe the first step needed to solve the system of equations using linear combinations method. Okay, we're not using substitution, we're using this one. We also call this elimination method. And we also call it the termination method for the terminator method. That was just a funny way of describing one variable being terminated. Identify the variable that you want to eliminate. Okay. For this one, if you study it carefully, you look at these and say, man, if this was -6, that would be cool. These would cancel out. Or if this was -6 and that was +6, that would cancel out. If this was 6 and that was 7, but that can't work. Maybe 42, if that was 42 and this was -42, that might cancel these out. And how did I get 42? I thought of a number that they both go into. And a cool way to do that is just to multiply them together. They definitely both go into that number. Sometimes you get half of that number and it works too. But 42, they both go into 42 because they both multiply to get to 42. Half of 42 is 21, and 6 does not go into 21. 7 does go into 21, but not 6. So you might want to say, man, if this one was -6, that'd be cool. That'd be sweet. Okay? So you could say multiply the top by -2. Multiply the first by -2, everything, and that'll become -6. Don't forget it. You got to multiply this by -2, this by -2, and this by -2. All three have to be multiplied. Okay. And you want to go ahead and do that. So I'm going to double everything and turn it opposite. See if you catch any mistakes here. I just made one. Remember I said everything's got to turn opposite, right? Opposite, opposite, opposite. And look at this. It's still positive. That's got to turn into a negative. Hi.
Hello.
And then you can rewrite your first equation and solve that out. Now terminator x says, cool, I will terminate the x's. And over here I have more negatives than positives. So that would be -5y equals -300. So 5 times what is 300? Well, 5 times 6 is 30. So I'm going to think it's 60. And notice that 60 is positive because positive times negative is negative. So this has to be positive because when you multiply by negative, you got to get a negative. So y is 60. So this tells you that there can be 60 students in the bus. And how can you figure out the van? Well, just get y equals 60 and plug it back here, multiply it times 6, then subtract it from 405 and divide it by 3. You can also plug it in here, multiply it times 7, subtract it from 516, and then divide by 6. So you need to do that. I won't get into that details because you've been practicing that already. Go ahead and finish that. All right, on the next page, you have another word problem continuing from the front. And you have to solve these algebraic systems here. And it's the same idea. Let's study this real quick. So that they can cancel. This one can cancel right away because that's 5 and 5. So the y's will disappear. This one, look at this. These can cancel each other, but one has to be -4, one has to be +4. Or this one can cancel if the top one becomes 2y, -2y. That could be another idea for you. Try different ways. And this is just a little review from our previous chapters. Recall that when it's a fraction, right here, you could bring it to the top by making a negative exponent. And same thing here, so it would be 4 to the negative first power, like this. So these two are the same. Okay, so you do the same idea for this one, but it'd be to the negative first. That's a -1. So then that would turn into negative x plus 6 equals 4. Okay, then you got to continue this to try to get, no, I'll stop here. Try to get the same base. So what times what is 4? Well, then whatever the exponent that you get, so 2 to the 2 squared is 2. So it'll be 2 to the -1 power. So it'll be 2 to the -2. Then you have the same basis, then you can solve the equation from the top. All right, guys, that's about it. Go ahead and struggle with this one and finishing this one off, and do the same idea here by bringing this to the top. Don't forget to keep it negative and with the -1 exponent. Submit your understanding of what is elimination method, termination method, or linear combination method. That's all the same thing. What is your understanding? Post that on our YouTube for the extra credit. Thank you. Hi. I'm subbing right now. Isn't that crazy? I know. All I had to do is take one class to peer helping. I'm gonna go get him now. Sweet. $50 just to walk him over there.
That's awesome.
Everyone except him that got in his face and shoved me. And they had to pull me back because I almost just clocked him.
Okay.
I told them,